Okay, this is Unit 3, Lesson 8, second semester, 7th grade math. Vocabulary review. What is the division property of equality? Who remembers that? Miranda.
When you divide both sides of the equation by the same number to make it.
Okay. For a true equation, you can divide both sides of the what? Of the what? Of the equal sign. Equal sign. And the equation remains true. Are we good? Does that make sense? All right. Let me give you an example. What I mean about that. So I'm going to come up with a statement. And it's going to, and you tell me if it's a true statement. Is that true? Yeah. Right. So if I divide both sides by 4, it should be true still, right? If I divide 4 by 4, and if I divide 8 halves by 4, I should have a true statement come back, right? So let's go ahead and do that. Divide by 4. And over here, I have a fraction divided by another fraction, 4 over 1. Does that make sense? Did you guys see what I just did? Yeah. Okay. Now, we know that 4 divided by 4 equals what? This is going to equal 1, right? And then over here, I'm going to rewrite this. Do you guys remember how to divide fractions? Yeah. How do we divide fractions? Keep, change, flip. So what am I going to keep?
You're going to keep 8 over 8 halves.
8 halves.
You're going to change the symbol.
I'm going to change, what's the symbol going to become?
Multiplication.
Multiply.
And then you're going to flip 4 over 1.
And 4 over 1, when I take the reciprocal and I flip it, what's it going to become?
1/4.
1/4. Okay. And so when I simplify that, do you guys remember how to multiply fractions?
Yes.
What's it going to become? Numerator is going to be what?
8.
8. Denominator is going to be what? 8. What's 8 divided by 8, or 8 over 8? 1. So do you see that we still have a true statement? And we use this property to solve and isolate variables of an equation, right? Right? Not just division property of equality, but we use what else? Multiplication property of equality. There's another property. What's the other property? Addition property. There's one more that we covered. Subtraction property of equality. So we're going to use these properties of equality to isolate a variable within a function today, to rewrite and create ourselves, the book says transform the formula. Okay, we're just isolating for whatever variable we want to find. So for a single variable equation, that's really easy. Okay, we already dialed into that. These are one-step equations. Okay, so how do we isolate A on number 2? Who's got this one? Somebody raise their hand, volunteer. Please don't call out. Michaela, what am I going to do? I want A by itself, right? So I got 5A equals 9. That's 5 times A. You're correct. I got to divide both sides by 5. Okay? And Michaela, what happens to my 5s on the left-hand side? They become what? What do they become? Don't say 0. Becomes 1. So I got 1A equals 9/5, right? And then 9/5, I can simplify that, right? 9/5, what kind of fraction is that? That's some more review. What kind of fraction do we have? Improper fraction. Can we rewrite that another way?
Yes.
How would we rewrite that?
1 4/5.
So 5 goes into 9 how many times without going over? one time. And then what would the remainder be? 4. And the denominator stays the same, 1 4/5. Got it? A equals 1 4/5. If I multiply 1 4/5 times A, or times 5, I get back 9. Okay, we good? So let's take a look at number 3. Actually, I'm going to move this over here. Let's take a look at number 3. Well, how do I get solve for t over here? Who's got this one? Robert? Why would you divide by 12? There's no variable on the side with 12. I want to isolate my variable. So I look at the side that's got the variable. It's the right-hand side. And with the variable t is 4.5 or 4 5/10. That's the number I need to get rid of. Okay, so you said it correctly. I want to divide both sides by 4 5/10. Now there's 2 ways that you can go about this. And I want to show you both ways because I feel like you need the review. And I want you to start seeing that a lot of things in math, there are many different ways to go about it. Okay? Well, first of all, when you have a fraction like this, we can always do long division, right? So what happens to my 4/5 on the right-hand side? They cancel out, they become 1. So then I get 1t is equal to whatever this fraction is going to be. Well, we need to calculate that, right? And if you're a fraction, which number goes in the house and which number goes out of the house? The numerator is in the house. Very good. So 12 is in the house, and then the denominator is out of the house, right? Now, the number outside the house, we don't like it like that, do we? What do we got to do to fix it? I got to move it one place to the right because what am I trying to do with the number outside the house? I got to make it a whole number. But if I do that, however many places I move it to make it a whole number, I got to do the same thing with the inside. Got it? Yep. A lot of you guys are forgetting that step. So if my decimal's here, I got to move it. I got to do something else too when I move it. What do I have to move? I got to annex a 0, right? So I'm going to move it right here. Okay, and I'm just going to put another one just in case. If we use it, great. If not, okay. Now, will 45 go into 12? No. Will 45 go into 100?
Yes.
How many times?
2.
You're saying 2? Okay, so 2 times 45, that is 90. Let's subtract that. So 120 minus 90, what do we get? 30. Very good. I'm going to bring down my 0. How many times does 45 go into 300? 6. I need to make sure I move this decimal up. Also, I forgot that. So you guys are saying 6? Okay, let's try 6. 6 times 5, 30. Carry my 3. 6 times 4, 24. Plus 3, 27. Now we're going to subtract. I get 30, and you probably notice we're going to start having a pattern. It's just going to be a 6 again, so it's going to be 2.6 repeating, right? Now there's another way we can do this. I'm going to show you another way. You know what fraction we get when we're 6.6 repeating, right? What fraction is that? You know what 0.3 repeating is, what? What's 0.3 repeating as a fraction? A third, right? So 0.6 repeating is 2/3, right? Okay, remember? All right, so I'm going to put this off to the side because I want to review, I want to review some fractions with you and show you that we get to the same place we would as when we divided it. Now, I can rewrite this as 12 in my numerator. How do I rewrite 4 5/10 as a fraction? 4 1/2. Good. A lot of you guys said it right at the bat. So this is 4 1/2. And then can I rewrite 4 1/2 as a improper fraction? What's 4 1/2 as an improper fraction?
9.
So this is the same as 9 1/2, right? So I'm going to go and put 9 1/2 in the bottom. Okay, now this is very similar to what we did up above, right? I got a whole number 12 divided by a fraction, 9 over 2. And so this whole number 12, I'm going to rewrite it as 12 over 1 divided by 9/2, right? Does that make sense? Now, you guys remember how to deal with dividing fractions, right? How would I rewrite this? Keep, change, flip, right? So what's my keep? 12 over 1. What's my change? I got to multiply. What's my flip? 2/9. Very good. And this is all equal to this t over here, right? Because 1t ends up just being t. Okay, so what's my numerator going to be? 24. And what's my denominator? 9ths. That equals t. And that's an improper fraction. Can we simplify that? What's it going to simplify to? 9 goes into 24 how many times? Twice, because that's going to be 18, right? So 2. And then what's left over if I can only get to 18? It's going to be 6/9, right? Isn't that what I just said what 0.6 is going to be? Okay, so you see the two ways we can get to the same place? That's 2 2/3. That's 2 2/3. Okay, last thing, number 4. Who's got number 4? Okay. Chin, walk me through it. What am I doing? Well, first we got to find which side's got my variable. There's a 4 with the side that's got my variable, right? What's happening with my variable in 4? What's going on between p and 4? That's divide. So we want to get p by itself. So how do I undo divide by 4? Multiply both sides by 4. So I'm going to multiply this side by 4 over 1. And this side, I'm going to multiply by 4. Got it? What's my fraction on the left-hand side going to become? 4p over 4. And that's going to equal, what's negative 8 times a positive 4? No, you're about to say it, and then you second guess yourself. Negative 32. I like that you got the sign right. The other stuff, we can work on that. What happens to my 4s? They divide and become what? They just become 1, but we know 1 times p is just going to be p. So p equals negative 32. Okay, are we good? Any questions about the warm-up? This is all old things coming back, and we're starting to see how things fit together. All right, here's what we're working on today. I'm going to go ahead and read this to you since I want to put this on the class YouTube channel. What you'll learn, to solve for a variable. Why learn this? Albert Einstein discovered the relationship between mass, energy, and the speed of light. The formula E equals mc squared shows this relationship. Okay? A formula is a rule that shows a relationship between 2 or more quantities. Here's the key. 2 or more. That's what a formula shows. Okay? If there's just one variable, not a formula. Got it? It's got to be 2 or more. Know that. We're going to see this question come up. You can use the properties of equality to transform a formula and solve for a variable. Example, transform a formula. The formula for perimeter of a rectangle is perimeter equals 2 times the length plus 2 times the width. Solve for L. So can you guys isolate for the variable L? Give it a shot. This is what you're going to be doing. We don't know what the length is. We don't know what the width is. We don't even know what the perimeter is. But we're trying to solve, and the book describes it as transform the formula. But all you're doing is you're using the inverse operations to isolate for the variable L, length. You guys take a stab at it. See if you can get it. Try to solve this for L. tomorrow your first try. I can't help you tomorrow. We have a test tomorrow. First part. Second part, the day after. So I'm puzzled. Some of you guys are confused. This has been here since February 19th. This has been up. Tomorrow, part 1, part 2 the next day. I need you to try. Isolate for your variable L. There's 2 ways to go about this. Now, when you isolate for a variable, remember, once you've simplified everything the best you can, you work backwards PEMDAS. Okay? Remember? So first thing I got to look for is add or subtract. Is there an add or subtract I can get rid of? What? Not subtract 2. I got to use that as one whole thing. I got to subtract 2w. So watch this. Minus 2w from both sides. Well, if I have a giraffe and I take away a giraffe, what do I have left? Nothing. So if I have 2w and I take away 2w, what do I have left? I have nothing, right? So this becomes 0 or nothing. So I get 2L plus 0 equals P minus 2W. We good so far? Now we know anything plus 0 is just the same thing, right? Okay, so I just want you to understand why this cancels out, becomes 0, but mentally you should know that all I'm left on this side of my equation is 2L, right? Okay, so how do I get rid of the rest of it so I have L by itself? What? What's happening? What's on the side with the variable? Is there any add or subtract left? You see an add or subtract going on with the side that's got L? No. So we're done with add and subtract. Now we got to do the next thing. We got to look for a multiplier divide. Do we have a multiplier divide? Yes. Multiply what? 2 times L. So now how do I get rid of 2 times? Divide by what? So we're going to divide both sides by 2. And then this 2 becomes what? It doesn't become 0. Don't say it becomes 0. It becomes 1. And then 1 times L is just what? It's just L. So here's my new formula. L equals, so the length equals P minus 2 times the width, all divided by 2. That's the formula for the length. If you have the perimeter and you have the width, you can plug it into this formula to get the length. Do you understand? That's transforming the formula. I don't know what L is. I don't know what W is. I don't know what P is. But if I did know P and W, I would use this formula to solve for L. Do you guys understand? Now let me show you another method. And this should take you back to the portfolio we did for distribution property. I can use reverse distribution here. You guys see I got a 2 in front of the W in front of the L? How would I do reverse distribution here?
L plus L plus W plus W.
Let's take a look at this. 2 is multiplied both to L and W. You guys remember this from the portfolio assignment? They had you using distribution property in one way, and then they had you using distributed property the other way, right? Okay, so this one's a little bit easier now that we've done this. There's a couple extra steps with fractions at the end, but watch what happens. How do I get my variable first? What's the first thing I got to do? Now, I can't take care of anything in the parentheses. Okay, so I got to look at this. So what's the first thing I got to do? I got to divide out. I can't get rid of this. It's kind of trapped inside there. Okay, so now I got to see if there's a add or a divide or a multiply to take care of. There is, right? What am I going to divide by?
2.
Okay, this 2 cancels out, right? Now I have P over 2, and then what do I have left on the left-hand side? Just L plus W. Okay, now how do I get L by itself now? I got to subtract W. Whoever said that, good job. Okay, now something's going to happen here. This is P over 2. And when we subtract fractions, they have to have what? And what has to happen in order for us to be able to subtract fractions or add fractions?
SP over 1. SP a fraction.
Well, I could think about it minus W as minus W over 1, right? But it's got a denominator of 1, right? How do I fix it so it has the same denominator as P over 2?
Multiply by 2.
Okay, so what would my new fraction be for a negative W?
2W over 2.
Minus 2W over 2. Very good. And that's all going to equal L. Now we can actually simplify that, right? So remember, you take the difference in the numerators and you keep the denominators, right? So what is my new formula going to be? P minus 2W over 2 equals L. Isn't that what we did earlier? Well, the 2's would cancel out. Wouldn't that be, if the 2's cancel out, wouldn't that be negative 1W or just negative W? So remember, when you add and subtract fractions, you got to get a common denominator. Okay? All right. All right, here's what I want you guys to do. Those were pretty challenging. So we're gonna work on these equations. We're going to isolate the variable for x. And are these formulas? Yes, why? 2 or more what? Okay. Let's go ahead and solve these for x. Okay, how are we going to isolate my variable for x here? What's the first thing I need to do?
Plus 4.
Very good. I look at the side with my variable, and I see if there's anything I can add or subtract first. Since I have a minus 4, I undo minus 4, and I add 4 to both sides. Okay, so what does my left-hand side of the equation simplify to become then?
4y.
Not 4y, that's 4 times y. That we didn't multiply by 4. Can somebody help him out? Y plus 4. So y plus 4 is going to equal what? Equals 2x, right? Because this became a 0, and then 2x plus 0 is just be 2x, okay? Now, I'm almost there. What's the next thing I got to do? Get x by itself. I don't have any add or subtract on the side of the x, so I'm going to go ahead and divide both sides by 2. Very good. Now, my 2's on the right-hand side, what do those become?
X.
The 2's become what? 1. And then 1 times x is just x. So I got x equals y plus 4 over 2. Oops. Okay, we good? I solved the equation for x, or I isolated x in the formula. We don't know what y or x is. We're done. Okay? I'm going to show you, you're going to see why we're doing this here in a little bit. Okay, so this next one, who's got the answer for this next one? Nima, what's this next one? How do I get x by itself? Hold on a second. I made a mistake. You know why? It's already by itself. Here's what it should be.
That's how I find it. No. What's that when you do X, not Y?
That was a typo, my bad. Here you go, fixed it. Okay, how do I isolate my variable for x? I gotta get x by itself. What do I do? Add what? Add 3 to both sides, very good. So I'm gonna add 3 to both sides of my equation. Okay, so what is my left-hand side of the equation gonna look like? Nima? Y plus 3. So I got y and I added 3 to it. So now on the left-hand side I got y plus 3. And that's going to equal what? Well, minus 3 plus 3 becomes 0, right? But I have something else there, right? On the right-hand side of the equation, what's left over there? What's left on my equation now? No, 3's gone. X is what we have left. Because these things became 0, and then x plus 0 is just x. All right, and that's my answer. I got x by itself. X equals y plus 3. Okay? All right, the next one, who's got this one over here? Joel, what do I do? I'm going to add 5 to both sides. Okay, Joel, what do I have on the left side of my equation? Right, so I got, hold on, let me get caught up. I got y plus 5, and that equals what? Not x. You just made something disappear. It equals 2x. Now, what did disappear was the minus 5 plus 5. That became 0 plus 2x. So 0 plus 2x is just 2x. Now I'm not done yet. I got one more step. X is almost isolated. I got to divide both sides by 2 now. Boom, boom. What happens to my 2's on the right side? They don't become 0. They become 1, and 1 times x is just x. So over here, I have x equals y plus 5 all over 2. Are we good? Okay? Let me show you why we do this now. Because a lot of you you want to get a number answer. Okay? Here's why we're going to do this. So, you can transform formulas to solve real-world problems. First, solve for the desired variable, then substitute the values you know. Okay? So here, the application savings. Your bank account has an annual interest rate of 5 7/10%. How much should you invest in order to earn $100 in interest each year? So let's just make this a simple interest formula. What is the formula for simple interest? I equals very good. P times R times T. Okay, now the question wants us to find what? How much we're going to invest, right? So if we're investing, what is that? Which variable is that? That's the principal. That's how much I'm putting into the account, right? So we want to know how much we're going to invest. So you have to understand the question. That's number one. So guess what we're going to isolate my equation for? No, we're trying to find out how much we're going to invest. You just said that's the principal. So we're going to isolate for what? P. Can you guys isolate this for P really quickly? Isolate that. I need you to recreate the formula so we're solving for P. Because now you're going to see why we're doing this. Solve it for P. See if you can get this. Just solve for P. Solve for P like we did the last 4 examples. We're almost done, really close. Okay. Who can tell me the new transformed formula? Chin, you got to guess.
57.
No. I didn't want a number. I didn't want to answer. I want a new formula.
What do you call it? Wait, 57.
I don't want numbers. I just want variables.
No.
Miranda, you think you got it?
Yeah.
What is it?
100 equals.
No. You guys didn't hear anything I said. You need to rewrite the formula.
He said solve for P. What does that mean?
Stop. This formula right here. This formula right here. I don't want you substituting yet. I want you to transform the formula so that you have P on one side of the formula.
P
Just like we solved for x, now you're solving for p. No, you're giving me numbers. I don't want numbers right now.
P equals I
No, like,
divided by R.
not P times R.
That's part of it. So look, how'd you get I divided by R? What'd you do?
You have to.
No, you're right. What'd you do? You're trying to isolate p.
I had I equals P times R, so I divided
Look at this side with p. Look at this side with p. What's on the side with p?
R and T.
Okay, what's happening between p, r, and t? That's all multiply, right? So how do I undo multiply? So what am I going to divide by if I want p by itself? I want to divide by r and t. There you go. So watch. Shh. Look at this. Here's what we got. I'm going to divide both sides by r. I'm going to divide both sides by t. Now, what happens to r on this side of my equation? It becomes what? No, it doesn't become 0. It becomes 1. What happens to t divided by t? Cancels out, becomes 1 again. So what's left on this side now? P. So here's my new formula. P equals, so Miranda was really close, is equal to the interest divided by the rate multiplied by the time. Okay? So do you understand what they mean by transform the formula now? So now we have a new formula where if we substitute all our numbers in, we'll know what p is. So let's go ahead and take this and substitute now. So here we go. Do you guys see what I just did with the equation? It's the same equation, I just rewrote it from here to here. Now is when you substitute so that you'll have p in the end. So what's in the numerator? That's not interest. $100 in interest. It says right here. So this is going to be 100. Okay, in the denominator, what's in the denominator? Oh, shh. Some of you guys jumped the gun. Somebody fixed it. Where's my, use the correct name of the number, please.
You have to annex a 0 before 5.
What is that number, ladies and gentlemen?
57,000.
And then, what's my t going to be?
1.
Nice. It's going to be 1. Okay. So, now I need you guys to calculate that out. So let's calculate this out. And then we'll know what my principal is. So we want to know how much do we need to put into my account so that after a year I get $100 on top of what I put in there. How much do I need to put into an account so that I get $100 back from the bank for leaving my money in that account? This is the formula right here. If that's my principal, $100 would be my interest. Here's my rate and time. We're trying to solve for that. No, you guys need to actually do your long division now. Which number's in the house?
100.
Which number's out of the house?
57,000.
But we don't like to have decimals outside the house, do we? So I need to make this right. How am I going to make this right?
Move the decimal place 3 times to the right.
3 places to the right. Very good. 1, 2, and 3. Okay. But I'm not done yet there, am I?
You have to move the decimal.
Okay. But I can't just do that. I can't move the decimal because why? I got to annex some zeros. So I at least have to annex 3 zeros. But we want to know how much money, so we're going to need to know 2 places past the end, right? Because we got to know how many pennies, everything. How much do we need to put into my account? So 1, 2, 3, 4, 5, because we're going to go 1, 2, 3. There's my decimal. We're going to need to know to the nearest penny how much we're going to put into that account. So here we go. Let's figure this out. So, how many times will 57 go into 100? Can it go in 100?
Yes, one.
How many times? One time, right? So 1 times 57 is 57. Let's subtract. What's my remainder going to be? What is it? 43. Now, what do I do next? Bring down to 0. How many times will 57 go into 430? Here, let me give you a trick. 57 is almost 60, right? Right? And then how many times will 60 go into 43? 7. 50 times, what? Shh, look. That, take off a place. Look, that's 43. 57 is almost 6. 6 goes into 43 how many times? 7, because 7 times 6 is 42. So we're just trying to rough estimate. So we're going to try 7. Let's see if 7 works. 7 times 7? 49. 7 times 5? 35. 35 plus 4? 39. Okay? Now, we're going to take the difference, or subtract this. What's it going to be? 30. Come on.
31.
Jeez. 31. Do I need to have everybody in here standing up? You guys are snoozing today. How many times will 57 go into 310? You say 5? Are you sure? Okay, we'll try 5. 5 times 7 is what? 35. Carry my 3. 5 times 5? 25 plus 3? 28. Subtract that. 310 minus 285. What do we got?
250. I mean, yeah, 250 if you bring down to 0.
30.
All right, do I need to go over regrouping with you guys? That's going to be 10. That's going to be 0. That becomes a 2.
It's 25.
Technically, it's 250 if you bring down
5, 2, 25. Now I got to bring down this other 0. Shh. How many times does 57 go into 250? Right, because we see that 5 gave us 285, so let's do 4. Let's do 4. Okay, so 4 times 7 is what? 4 times 7, what is that? Four times 7 is?
28.
Carry the 2. 4 times 5? 20 plus the 2. Subtract that, what do we get? What's that going to be? 22. Now look, so we know we have to put 1,754, but let's see how many pennies we got to put in there too. So I got to bring down my 0. How many times does 57 go in 220? 3. And then 3 times 7? 21. Carry my 2. And then 3 times 5 plus 2? 17. Subtract. 220 minus 171?
53.
49. Right? Because 71 to 100 would be 29 plus 20 more, 49. Bring down my last 0. Shh. How many times will 57 go into 490? Look over here. We saw that 430, we had to use 7, right? That gave us 399.
It's probably about 8.
I'm going to guess 8. Let's see if 8 works. And then we have our answer, I think. We're good. So what is 8 times 7? 8 times 7 is what?
456.
Carry the 5. 8 times 5, 40 plus the 5. 8 times 5, 40 plus the 5. 456.
Oh, Mr. Early.
Okay, what's my remainder going to be?
34. Wait. No, 34.
Come on, guys. This has become a 10. This will become an 8. 8 minus 5 is 3. 10, that's 34. If I put another 0 in there, is that going to give me a number to round up?
Yep.
I might have to round up 340.
Yes. It's going to give you 6.
You're saying 6?
Yes. Wait. Yes.
Okay.
Actually, no,
All right,
5,
so
5.
6 is too much because it gave me what? 399, right?
No, that's 7. 6.
285 was
6 gives you 342.
5. 6 was
342.
6 is good? So it's going to be 6?
No,
That's too much?
Yeah,
So it's 5. Definitely 5?
Yes.
All right, so how much do I need to invest to get $100 back at the end of the year? So the principal, that was a long problem, is $1,754.39. That's how much you have to put in. Now listen, shh. That one was the example given from the book. This one is more within reason. This one you should be able to do. Find the interest rate that yields $120 interest each year for $2,000. So again, first, shh. What's the formula for simple interest?
I equals PRT.
Got him.
And what are we solving for? P? Yep, I heard it. No. It says find the interest rate. They're giving you principal each year. That means 1 year. And that's the interest. You need to solve this, transform this formula for what? R. So first, before we even do that, I need everybody to take a time to rewrite this formula. We need to solve the formula for what? R. So what's it going to be? Michaela, what is it? I need an equation where R is by itself. What does R equal by itself? I still see some people writing. I see some people not even trying. Alexis, I haven't heard from you today. What is it going to be? We're not trying to find principal this time. We're trying to find R, the rate. Find the interest rate. So how to get R by itself? Atisha, what do you think it is? How do what's the first thing I see all the way in the back? Mason, what's the first thing I need to do? Step by step. You guys are just trying to guess your way to this. It's not going to work. What's the first thing I got to do to get R by itself? Shh. I shouldn't hear talking over here. Okay, so what variables am I going to divide by? Nice. So here's R on this right-hand side. I have a lot of side conversations. I need you to pay attention. We're almost done. This is the last example. Turn around, please. I need to get r by itself, so that means this p and the t, they got to go. So how do I get rid of p and t? Just like Mason said, you're going to do what? I'm going to divide both sides by p and t. So what happens to these two p's? They cancel out. What happens to these two t's? So what's my formula for rate going to be? Rate is going to equal what? I over pt. Now, this is actually a little less work. I know the last one was a little frustrating because you guys don't like to do long division. So I need you to substitute into this equation your values and then find the rate. And it is pretty easy. Some of you guys that started working out, you probably already got the answer. It's pretty easy. Jameson, I haven't heard from you. What goes in my numerator? What's in the numerator? What's interest? 120. Now, what goes in the denominator? 2,000. And then, what was time? Time was what? Each year, right? So it's just one. All right, so you guys know how to take 120 divided by 2,000. Don't give me decimal. We want what? Interest rate. So two things. You have to know how to get the decimal. Then you have to go backwards from the decimal to get the what? Percent. So get it done. This is the last problem. I know you can do this. You guys that have your hands up, I need the others to get caught up. Now I got everybody trying to get this because they see that you can get this. It's not that hard. Then all I'm going to do is serve the same person all the time. Nope, I don't want to do that. Shh. What's in the house, ladies and gentlemen? 120. What's out of the house?
2,000.
Okay, where's my decimal going to be? It's going to be right here, right? Going to add a couple zeros. Does 2,000 go into 12? No. Does it go to 100 or 200, 120? What about 1,200? No. 1,200 is less than 2,000. What about 12,000?
Yes.
How many?
6.
6. 6 times 2,000 is going to be 12,000. Subtract 0. But that's not my rate. What is my rate?
6%.
Okay. Could the equation be a formula? Is this an equation?
No.
No, why not? No variables. Is this an equation?
Yes.
Yes, why? More than 2. 2 variables. What about this one?
No.
Nope, not more than 2. Now, which operation must you use to solve each equation? How do we solve this one? We got to subtract 1 from both sides. So x equals what? 12. Over here, how do I solve this? I have to multiply both sides by 4. So what's this end up being? X equals what?
208.
208. Over here, how do I solve this one? Divide by what?
5.
X equals what?
5.
That is it for my lesson today.